हाँ, ये मोटो सामने वाला बड़ा मोटो सा करके बोलते हैं वो इधर है मोटो घोड़ के 5500 गुड मॉर्निंग सिनी राजलक्ष्मी सुप्रिया ठाकुर अनुर सिंह एक पट्टी उसने Good morning, students. Am I audible, visible? Please write in the chat box. So today we'll start. Today we'll start interesting topic of application of derivative. I think that is the last topic of differential calculus. That is maxima and minima. Maxima and minima. Maxima and minima. Okay. So guys, can you tell me what do you mean by maxima and minima? Can anybody tell me what do you mean by maxima and minima? Maxima and minima means maximum and minimum value of a function. Maximum and minimum maximum and minimum value of a function. Maxima and minima, otherwise known as extrema. Extrema or extremum. Okay. So maxima, minima are of two types, or extremum are two types. Local or relative maxima, local or relative minima. Local or relative maxima, local or relative minima. Global maxima, global or absolute maxima. Global or absolute minima. Okay. So guys, quickly note it down. So one by one, we will discuss what is local maxima, local minima, what is global maxima, global minima, what are the different methods to find the local maximum, extremum of a function, and what are the methods to find the local, global extremum of a function, right? Write down local maxima. A real valued function y is equal to f of x is said to have a real valued function y is equal to f of x is said to have local maximum a real valued function y is equal to f of x is said to have local maximum at x is equal to a if f of a greater equal to f of x for all x belongs to a minus h to a plus h. A real valued function y is equal to f of x is said to have local maximum at x is equal to a if f of a greater equal to f of x for all x belongs to a minus h to a plus h. Take a look at the graph of the function. Suppose the graph of a function is like this. This is x is equal to a. This is a minus h, where h is a very, very small positive number, and a plus h. So that means the function is attaining the maximum value with respect to its neighborhood points. Here the function. So x is equal to a is the point of local maximum. And f of a is the local maximum value. F of a is the local maximum value. I hope it is clear to you. Then write a local minima. A real valued function y is equal to f of x is said to have local minimum at x is equal to a if f of a less than or equal to f of x for all x belongs to a minus h to a plus h. Okay, this is suppose x is equal to a minus h, a plus h. The function attains the minimum value at x is equal to a with respect to its neighborhood points. That means in the interval a minus h to a plus h. Is it clear to you? Please write in the chat box. Hello. Okay, write down a note point. Sometimes local minimum value is greater than local maximum value. Okay. You see x is equal to a is a point of local maxima and x is equal to b is a point of local minima. Here f clearly from the graph it is clear that f of b is greater than f of a. So local maximum value is greater than local minimum value. Then write down necessary condition for local extremum. Necessary condition for local extremum. If a function attains local extremum if a function attains local extremum at x is equal to a, then first order derivative of the function vanishes at x is equal to a, that is dy upon dx at x is equal to a is 0. If a function attains local maximum at x, local extremum at x is equal to a, then dy upon dx at x is equal to a is 0. This is a necessary condition because the converse of the above theorem is not true. The converse of the above statement is not always true. The converse of the above statement is not always true. First of all, let me explain why the first derivative vanishes at x is equal to a. Take a look at the graph of a function. Suppose x is equal to a is the point of local maximum. Okay. With respect to its neighborhood points, the function attains the maximum value at x is equal to a, hence it is equal to local maximum. This is suppose a minus h. This is a plus h. if you want to move on the curve from A minus H to A, that is this portion. If you want to move, then you see, if you draw a tangent, this will be the inclination. If you draw a tangent, this will be the inclination. Okay. So inclination gradually decreases, and it is becomes zero at this position. If you draw a tangent at this position, then the tangent line will be parallel to x-axis. All of you know, if a line is parallel to x-axis, then its slope is zero. So at this point, dy upon dx is equal to zero. So in the left hand side of x is equal to a, dy upon dx is greater than zero. So value of dy upon dx gradually decreases. In the right hand side of x is equal to a, dy upon dx becomes negative because the inclination becomes acute. Okay. Clear? So again, take the case of local minimum. To draw a tangent line will be parallel to x-axis. So dy upon dx is equal to 0 at x is equal to a. Okay, then why the converse of above statement is not always true? To take an example, if you consider the function y is equal to f of x is equal to x cube, y equals f of x is equal to x cube. What is the first derivative of the function? Dy upon dx is equal to 3x square. Dy upon dx is equal to 0. Converse of the above statement is not always true. That means if the first derivative of a function at a point vanishes, that doesn't mean that the function attains local extremum at that point. So take the example of the function y is equal to f of x is equal to x cube. Its first derivative dy upon dx is equal to 3x square. Now equate dy upon dx to 0. Dy upon dx is equal to 0 implies 3x square is equal to 0. 3x square is equal to 0 implies x is equal to 0. So at x is equal to 0, first derivative of the function y is equal to f of x is equal to x cube vanishes. What do you see? Since its first derivative is 3x square is greater than 0, the function is strictly increasing. Since the function is strictly increasing, neither the local maxima nor the local minima will exist. So take a look at the graph of the function y is equal to f of x is equal to x cube. The x is equal to 0, the point x is equal to 0 is neither point of local maximum nor the point of local minimum. Okay. I think is it clear? It is clear to you. Did you understand, guys? Hello. Please write in the chat box. Rupriya, Rajalakshmi, is it clear? Quickly note it down. Then write down critical points. Critical points. The points at which first order derivative the points at which first order derivative of a function vanishes. The points at which first order derivative of a function vanishes or doesn't exist are called critical points. The points at which first order derivative function vanishes or doesn't exist are called critical points. Okay. The points at which, suppose y is equal to f of x, a given function, if dy upon dx at x is equal to a is equal to 0, or dy upon dx at x is equal to a doesn't exist, then we can say that x is equal to a is a critical point. Just a minute, guys. So critical point of a function may be the point of local maximum or the point of local minimum or neither of the two. Okay. Then write down first order derivative test for local extremity. First order derivative test for local extremum. Let y is equal to f of x be the given function step 1, find dy upon dx. Step 2, solve dy upon dx equals to 0. Right, let x is equal to alpha be a solution. Let x is equal to alpha be a solution. Step 3, step 3 bit a, if dy upon dx changes its sign dy upon dx changes its sign from positive to negative. If dy upon dx changes its sign from positive to negative when x moves from A minus H, sorry, alpha minus H to alpha plus H through X is equal to alpha then X is equal to alpha is the point of local max. Okay, would we note it down? ଲେଖି ସାରିଲା ପିଲେ explain କରିବା X is equal to alpha is the critical point. This is X is equal to alpha, alpha minus H. This is alpha plus H. In the left neighborhood of the point X is equal to alpha, dy upon dx is greater than 0. In the right neighborhood of the point X is equal to alpha, dy upon dx less than 0. So dy upon dx changes its sign from positive to negative. This is X is equal to alpha, alpha minus H, alpha plus H. In the region alpha minus 2 alpha, take a point on the graph of the function, draw a tangent. The inclination theta will be acute. If theta is acute, then tan theta greater than 0. Tan theta is nothing, slope of the line, and is determined by dy upon dx. Dy upon dx is greater than 0. So dy upon dx decreases and it becomes 0 at x is equal to a. Then if you take a graph tangent in the right neighborhood of x is equal to a, the inclination theta is obtuse. Then tan theta less than 0. That is dy upon dx less than 0. So if dy upon dx changes its sign from positive to negative, when x moves from alpha minus h to alpha plus h to x is equal to alpha, then x is equal to alpha is the point of local maximum. This is the point of local max. X is equal to alpha is the point of local maximum. Okay. Is it clear to you? पहले बुझी पारल कि चैट बॉक्स में लिखिके जणाओ. Then I done B part. If dy upon dx changes its sign from negative to positive, if dy upon dx changes its sign from negative to positive when x moves from alpha minus h to alpha plus h through x is equal to alpha if dy upon dx changes its sign from positive to positive when x moves from alpha minus h to alpha plus h through x is equal to alpha, then x is equal to alpha, then x is equal to alpha is the point of local minimum. X is equal to alpha, alpha minus h, alpha plus h. In the left neighborhood of x is equal to alpha, dy upon dx is negative. In the right neighborhood of x is equal to alpha, dy upon dx is positive. Dy upon dx changes its sign from negative to positive. So x is equal to alpha is the point of local mean. If you draw a tangent in the left neighborhood of the point x is equal to alpha, so inclination of the tangent line will be obtuse, theta is obtuse. So tan theta less than 0. So dy upon dx less than 0 in the left neighborhood of the point x is equal to alpha. The right neighborhood of the point x is equal to alpha, theta is obtuse. Tan theta is greater than 0. So dy upon dx is greater than 0. Clear? Then come to C part. If dy upon dx doesn't change its sign that is either it moves from positive to positive or negative to negative when x moves from alpha minus h to alpha plus h to x is equal to alpha, then x is equal to alpha is neither point of local max nor point of local minimum. Okay. If dy upon dx doesn't change its sign, that is either it moves from positive to positive or negative to negative. When x moves from alpha minus h to alpha plus h to x is equal to alpha, then x is equal to alpha is neither a point of local max nor point of local min. Okay. Okay. Suppose this is x is equal to 0 is a critical point. If you draw a tangent at this point, theta is acute. If you draw a tangent at this point, theta is also acute. Okay. So dy upon dx changes from positive to positive. So x is equal to alpha is neither a point of local max nor point of local min. I hope it is clear to you. Please write in the chat box. Is it clear? So discuss couple of problem questions on this concept. That means we have to find points of local maximum, local minimum, and corresponding local maximum, local minimum values using the first order derivative. Write down a question. Find the points of local extremum and corresponding local extremum values of the function f of x equals x square minus 5x plus 6 if exists. Okay, find the points of local extremum and corresponding local extremum values of the function f of x is equal to x square minus 5x plus 6 if exists. To come to the solution, f of x equals x square minus 5x plus 6. F of x equals x square minus 5x plus 6. This implies f dash x equals 2x minus 5. For local extremum, f dash x is equal to 0. for local extremum f dash x is equal to 0, this implies 2x minus 5 is equal to 0. This implies x is equal to 5 by 2. X is equal to 5 by 2 is the critical point. Now we have to find the sign of f of x in the left neighborhood of the point 5 by 2 and in the right neighborhood of the point 5 by 2. Okay. Let x belongs to 5 by 2 minus h to 5 by 2. So let x belongs to 5 by 2 minus h to 5 by 2. This implies x less than 5 by 2. This implies 2x less than 5. This implies 2x minus 5 less than 0 implies dy upon dx less than 0. In the left neighborhood of the point x is equal to 5 by 2, first order derivative is negative. Then check what is the sign of first order derivative in the right neighborhood of the point x is equal to 5 by 2. Again, let x belong to 5 by 2 to 5 by 2 plus h. This implies x is greater than 5 by 2. This implies 2x is greater than 5. 2x minus 5 greater than 0. So dy upon dx greater than 0, right? So we find that, sorry, dy upon dx less than 0 in the left neighborhood. In the right neighborhood, dy upon dx is greater than 0. So dy upon dx changes its sign from negative to positive. Dy upon dx changes its sign from negative to positive. Thus, x is equal to 5 by 2 is the point of local mean. X is equal to 5 by 2 is the point of local minimum. Quickly note it down. Okay, is it clear? ବୁଝିପାରିଲ ପିଲେ chat box ରେ ଜଣାଅ। Then come to next question. Find the points of local maximum and local minimum of the function f of x equal to sin x plus cos x in the region 0 to 2 pi. In the interval 0 to 2 pi, we have to find out the point of local maximum and local minimum. Come to the solution. F of x equals sin x plus cos x. This implies f of x or y is equal to f of x. dy upon dx equal to cos x minus sin x. So now solve dy upon dx is equal to 0. This implies cos x minus sin x is equal to 0. This implies sin x is equal to cos x. This implies tan x is equal to 1. Implies x is equal to pi by 4 or x is equal to 5 pi by 4. These are the two critical points. X is equal to pi by tan x is equal to 1. Either x is equal to pi by 4 or x is equal to 5 pi by 4. These are the critical points. Okay. Now we have to check the sign of first order derivative. First take the critical point. X is equal to pi by 4. Pi by 4 minus h. Pi by 4 plus h. Now we have to check what is the sign of the function or derivative in the left neighborhood of the point x is equal to pi by 4 and in the right hand neighborhood of the point x is equal to pi by 4. Okay. Let x belongs to pi by 4 minus h to pi by 4. This implies x is less than pi by 4. Okay. So what is the sign of cos x minus sin x? You know, cos x minus sin x. Cos x minus sin x can be written as root 2. ये सब तुम एलिमेंटरी ट्रिगोनोमेट्री पढ़ाला बेले पढ़ाइथबो root 2 into 1 upon root 2 cos x minus 1 upon root 2 sin x. So 1 upon root 2 is cos pi by 4. So this is equal to root 2 into cos x plus pi by 4, right? Root 2 into cos x plus pi by 4. So first order dy upon dx. dy upon dx that is equal to cos x minus sin x can be written as root 2 into cos of x plus pi by 4, right? So x less than pi by 4. This implies x plus pi by 4 less than pi by 4 plus pi by 4. Pi by 4 plus pi by 4 is pi by 2. So x plus pi by 4 less than pi by 2. That means x plus pi by 4 lies in the first quadrant. In first quadrant, all trigonometric functions are positive. Now this implies cos x plus pi by 4 is greater than 0. बहुत पिला कौन करते हैं cos लगे देखी less than symbol असली less than लिखी दियंती. Cos x plus pi by 4 greater than 0. This implies root 2 into cos of x plus pi by 4 greater than 0. This implies dy upon dx greater than 0, right? In the left neighborhood of the point x is equal to pi by 4, dy upon dx is greater than 0. Then come to right hand neighborhood of the point x is equal to pi by 4. Let x belongs to pi by 4 to pi by 4 plus h. Let x belongs to pi by 4 to pi by 4 plus h. This implies x greater than pi by 4 This implies x plus pi by 4 is greater than pi by 2. That means x plus pi by 4 belongs to second quadrant. In second quadrant, cos function is negative. Thus, this implies cos x plus pi by 4 is less than 0, implies root 2 into cos x plus pi by 4 is less than 0. So dy upon dx is less than 0. In the left neighborhood of the point x is equal to pi by 4, dy upon dx is greater than 0. In the right neighborhood, dy upon dx is less than 0. Dy upon dx is less than 0. So dy upon dx changes its sign from positive to negative. So x is equal to pi by 4 is the point of local maximum. X is equal to pi by 4 is the point of local maximum. X is equal to pi by 4 is the point of local max. Thus, and local maximum value is f of pi by 4. F of pi by 4 is equal to sin pi by 4 plus of cos pi by 4. Sin pi by 4 is 1 upon root 2 plus cos pi by 4 is 1 upon root 2. So 2 upon root 2 is root 2. So local maximum value is root 2. এটা বুঝি পারলো পিলে? সুপ্রিয়া, বুঝিয়ে রাখরে? Raju Lakshmi, is it clear to you? Another critical point is that is 5 pi by 4. Now we have to check whether 5 pi by 4 is the point of local maximum or point of local minimum. Is equal to 5 pi by 4. So dy upon dx is equal to cos x minus sin x. This is equal to root 2 into cos x plus pi by 4. All right? Five pi by 4 minus h, 5 pi by 4 plus h. So let x belong to 5 pi by 4 minus h to 5 pi by 4. This implies x less than 5 pi by 4, x plus pi by 4 less than 6 pi by 4. That is 3 pi by 2. Okay. So that means then 3 pi by 2 means this quadrant, third quadrant, cos is negative. So x plus pi, cos x plus pi by 4 less than 0, or root 2 into cos x plus pi by 4 less than 0. So dy upon dx less than 0. Okay. Then again let x belongs to 5 pi by 4 to 5 pi by 4 plus h. This implies x is greater than 5 pi by 4 So x plus pi by 4 is greater than 3 pi by 2. Greater than 6 pi by 2 means half fourth quadrant. In fourth quadrant, cos is positive. So dy upon dx changes its sign from negative to positive. The point of local minimum. And the local minimum value is f of 5 pi by 4. That is minus root 2. Quickly note कर दिया. Okay. Then come to another question. Of x is equal to e raised to the power x square minus x. Okay. Find the points of local extremum of the function f of x is equal to e raised to the power x square minus x. Derivative of x square minus x is 2x minus 1. Or an extremum dy upon dx is equal to 0. So e raised to the power x square minus x can never be equal to 0. So only this term will be equal to 0. That is 2x minus 1 is equal to 0. Implies x is equal to 1 upon 2. This is the only critical point. Now we have to decide whether this point is point of local maxima or point of local minima or neither of the two. Right? 1 by 2, 1 by 2 minus h, 1 by 2 plus h. 1 by 2, 1 by 2 minus h, 1 by 2 plus h. Let x less than 1 by 2. This implies 2x less than 1. This implies 2x minus 1 less than 0. And you know, e to the power x square minus x is always positive. Implies e raised to the power x square minus x into 2x minus 1 is less than 0. This implies dy upon dx is less than 0. Again, let x greater than 1 by 2. This implies 2x greater than 1. This implies 2x minus 1 greater than 0. So e raised to the power x square minus x into 2x minus 1 is greater than 0. This implies dy upon dx is greater than 0. Dy upon dx changes its sign from negative to positive. So x is equal to 1 by 2 is the point of local mean, local minimum. Quickly note करो प्ले. Note question लो. Next page बा. Lecture लो कितने. The next question. Find the points of local extremum of the function f of x is equal to ln x upon x. F of x equals ln x upon x. Derivative of ln x is 1 by x into x minus ln x into derivative of x is 1 divided by x square 1 minus ln x upon x square. For an extremum, dy upon dx is equal to 0. This implies 1 minus ln x upon x square is equal to 0, implies ln x is equal to 1, right? So ln x is equal to 1 implies x is equal to is the critical point. Right? E minus h, e plus h, x belongs to let x less than e. This implies ln x less than 1. This implies minus ln x. Sorry, 1 minus ln x greater than 0. 1 minus ln x upon x square greater than 0. So dy upon dx greater than 0. Right? Then come to right neighborhood of the point x is equal to a. X greater than e. This implies ln x greater than 1. 1 minus ln x less than 0. So dy upon dx less than 0. So dy upon dx changes its sign from positive to negative. Dy upon dx changes its sign from positive to negative. So x is equal to e is the point of local max. Municipal play. So today's session is over. So rest of the thing we'll discuss in the next class. Okay.